Kia ora, Year 11. This is a revision video going over what you learned about Pythagoras' theorem in Year 10. So it's going to go a little bit faster than I would if I were teaching it from scratch. I'm hoping that quite a lot of stuff will come back into your brains once you go through it. I'm going to do 6 examples in this video. None of them are word problems. We're just going to work with 6 triangles, and I've used Dr. Austin Maths for her lovely examples. And just to give you a heads up, the first 2 in here are going to be the easiest type of Pythagoras problem, where we're finding the hypotenuse, the long side of the triangle. Then the next 2, this one here and this one here, are where we're finding the short side. And then the last 2 are slightly more difficult. But we're going to go all the way back to the start by just looking at some right-angled triangles and see what we're talking about. So when we're working with Pythagoras' theorem, the theorem is going to tell us this. Now this is a really, really boring way to explain Pythagoras' theorem, but we're going to have 3 side lengths. We always will call the short sides A and B, and we don't care which way around it is. So they're A and B, and then the hypotenuse, the long side, is side C. So the very first thing we do, as soon as we spot that we know 2 sides and we need to find a third, is to label A, B, and C. And then we can write down Pythagoras' theorem. And then we start substituting in values and evaluating whatever thing is missing. So just quickly, here are a few more triangles. So the A, B, and C will go like this. A and B will be those 2 sides. C will be that side. In this one here, here's my right angle. So the 2 short sides will be A and B around the right angle. And this will be the hypotenuse over here. And I think there's one left. This one here. Oh, where's it gone? Here we are, A and B, and the hypotenuse is C. All right, let's get into the 6 problems. I've done them up a little bit bigger here, and I've started off with just doing some labeling on this very first one, but let's start from scratch. So I'm going to make this side A, and this side B, and this side C. So we can write out 5 squared plus 8 squared is equal to x squared, right? What I'm doing there is I'm substituting into a squared plus b squared equals c squared, right? And so a is 5, b is 8, and we don't know what c is, but we're calling it x. So substituting in those values gives me 25 plus 64 is equal to x squared. So x squared is 89. I take the square root of 89, and that's my x value. Now I know that it's got to be a positive number, so that's why it's the square root of 89, not negative the square root of 89, and it's got to be centimetres. So when I put that in my calculator, I will get out 9.433981 is equal to x, and I want to round that sensibly. So for me, the way that I'm going to think about that is that these numbers have been given to the nearest whole number. So I'm going to round it to one more decimal place. So we'll say that x is equal to 9.4 centimetres, and that's to 1 decimal place. Okay, so that's that first one done. Right, now the second one is very similar, because again we're finding the long side or the hypotenuse. So we're going to make A will be 22, B will be 35, and X will be C. So we have 22 squared plus 35 squared is equal to X squared. Putting those in my calculator gives me 484 plus 1,225. So that's X squared. X squared is equal to 1,709. Now I'm going to take the square root of that, and that works out to be 41.34005. I'm going to write that as 41.3 millimeters. Just watch out for the units, and that's to 1 decimal place. Okay, so 2 examples there where we've been missing the hypotenuse and we've had the 2 short sides. Now the next 2 examples are ones where we know the hypotenuse, but we don't know what this is, one of the short sides. Okay, so I'm going to start with this question down here because the numbers are slightly less mucky. And again, we start with labeling, right? And I'm going to make the one that we know I'll call A, the one that we don't know is B, and then C is 14. So we just need to be a little bit more careful thinking about how we do our substitution here. So we've got A squared plus B squared is equal to C squared. So we have 11 squared plus X squared is equal to 14 squared. Substituting gives me 121 plus X squared is equal to 196. So X squared is going to be equal to 196 minus 121. Right, I'm subtracting 121 from both sides. So that gives me an X squared value for that one of 75. Now I take the square root like I did before, so X is equal to the square root of 75 and rounded to one decimal place. So that gives me 8.6602 blah blah blah, and that's equal to 8.7 centimeters, and that's rounded to one decimal place. So there is slightly more work with the algebra here, guys, but it should feel by year 11 this step here should feel really, really easy. I know that sometimes when you're in year 10 and you're first learning that, or year 9, you're still thinking about how to solve simple equations and the idea of the inverse operation, but that should be very easy by this point, by halfway through year 11. Okay, so let's do one more like that, and then we'll do the last two where we have to think a little bit harder. So again here we've got A, B and C to start off with labeling. We'll call the side that we know A, the side that we don't know we'll call B, and the hypotenuse is C. So we have A squared plus B squared equals C squared. 17.2 squared plus X squared is equal to 23.9 squared. Now, I don't know why I picked that example where they're yucky numbers, but actually, in real life, this is quite often going to be the kind of situation that you've got, right? The numbers won't always be nice integer values. So what does my working look like here? Well, I've got 295.84 plus X squared is equal to 571.21. Now, don't round any of those numbers, or we're going to lose accuracy quite badly. Now we get X squared is equal to 571.21 minus 295.84, which is, what does that give me? 275.37. So that's not my answer, that's what X squared is. So X is equal to the square root of that, and that gives me, so unrounded, that gives me 16.59428 which is equal to 16.6. I think I'm working with centimeters, 16.6 centimeters to one decimal place. Or you could go one more accurate than what we were given and do 16.59 centimeters to two decimal places. I'd be happy. I guess I'd be happy with either of those. I think that one is slightly better. Okay, right, so they are the four basic ones, and if you are in my class and you're looking at Dr. Frost revision, that's what will be in the level 1 Dr. Frost revision work. But the next two are ones where we just have to think a little bit more and link up our year 9 geometry stuff. So in this next one, you can see that we've got a right angle triangle, and you can see that this side here is going to be the hypotenuse, which is C, and this side is one of the short ones, so that's A. This side here, which is B, we know that's 21 millimeters because we know we've got an isosceles triangle. So we can just write 21 on there. And now we've got A squared plus B squared is C squared. So I have 21 squared plus 21 squared is equal to Y squared. So that one's really no more difficult than the earlier ones, as long as we spot that we've got an isosceles triangle, which is what those little lines are doing. That gives me 882 is equal to Y squared. So Y is equal to the square root of that, which is 29 point, let's see. So out of my calculator comes 6, 9. 848, and that gives me 29.7 millimeters, which is a very, very small triangle, and that's to 1 decimal place. Okay, so I think that that problem really isn't much harder at all than the ones we've been doing. Again, we label, and then we substitute, and then we evaluate. But this next one we do just have to think about a little bit harder. I'll just give us some space here. So hopefully the whole way through you've been copying all of this into your books nicely. If you haven't, please make sure you get this one down. So here we've got a right angle triangle. This side is going to be A, and this side is the hypotenuse, so it's going to be C. Now, this time, the thing that we know is the hypotenuse, and so if this side is A and this side is the same length, then this side is also going to be A. So we've got two equal short sides missing. So we only know one side of the triangle, but we know that the two short sides are the same length. So this structure is different from the one before, right? Because if you look in the previous question, the thing that we had is that we had this short side length, and we also had that short side length, right? So we had two side lengths, and we knew they were the same. And here, we've got two missing side lengths, but we know they're the same. So let's just work through the substitutions. So usually we have a squared plus b squared equals c squared, but here we know, because it's an isosceles triangle, that we have a squared plus a squared is equal to 12 squared, right? So again, because you're in year 11 and it's a revision video, the algebra here shouldn't feel too bad, right? So we've got a squared plus a squared. We've got 2a squared, right? Adding my like terms, 2a squared is equal to 144. That gives me, dividing both sides by 2, a squared is equal to 72. So a is equal to the square root of 72, which will work out to be 8 point something. Let's have a look. So a works out to be 8.48521. So rounding that, I'll round that to 8.5 centimeters. Okay, so that's A, and that's Y. We've called it Y in there. I should have switched that over. So length Y is 8.5 centimeters to 1 decimal place. And you can check that going backwards the other way, and it works out. Okay, so that's how we do that one. That's quite a long video, so well done if you've watched all the way to the end. My plan for tomorrow is to do some revision on sine, cos, and tan, probably 2 or 3 videos on that. So if you have got any questions that you want answered that you're not sure about, just send me an email and I'll put them into the next couple of videos. Thanks for watching.